Hi, everyone. Again, this is going to be the last day to expect notes like this. If you do not like it, if I get feedback on last Friday that you guys like this, then I'll continue doing this. But if not, this will be the last day that you will have notes like this from me. Okay? So, last couple days that we have class, we've been talking about exponential growth, where the A value was greater than 0, the B value was greater than 1, and now we're going to be talking about exponential decay. Okay, exponential decay. And so we can be able to tell whether a function is exponential decay from both a graph or a table, but right here, tell whether the table represents an exponential function, and if so, write a rule for the function. So really what we need to do is remember the rule of exponential functions, and if I can get a pen that works, really the rule for exponential functions is y is equal to ab to the x. Y is equal to ab to the x. Okay, and remember with tables, exponential functions, and let me actually give that back in here, linear functions occurred when we added the same number over and over again to our y values. Exponential functions occurred when we multiplied the same number over and over and over again. So really what we need to do is check, okay, all of these are going up by 1. That has still stayed the same. All of these are going up by 1. But what is happening to my y values? What am I doing to each time? Well, between 1/9 and 1/3, well, that might not be very clear. But let's check between maybe 1/3 and 1 or 1 and 3. What do I have to do? Am I adding the same amount between 1/3 and 1 and 1 and 3? Well, here, between 1/3 and 1, I'm adding 2/3. Between 1 and 3, I'm adding 2. So that tells me I'm not adding anything. I'm not adding the same amount each time. And so what I have to do is, okay, let's check multiplication. 1/3 times by what gives me 1? Well, I know 1/3 times by 3 gives me 1 because 3/3 gives me 1. Similarly here, 1 times 3 does give me 3. And then 1/9 times by 3, although it's fractions, I know that that is 3 because 1/9 plus 1/9 plus 1/9 is 3/9, and 3/9 is equal to that 1/3 if I reduce that fraction. And so if I were to write this as an exponential function, this would be y is equal to a, and remember a was this value of, it was the value of x when, the value of y when x was equal to 0. Well, x is equal to 0 here, so what's the value of y? Well, that's 1/3. So my a value is 1/3. And my b value is what we're multiplying each time here. So my b value would be 3 to the x. Okay, and what we notice is as our x values increase, our y values increase. And so what's going to happen is our function is going to be increasing. However, when I get to point B, if I do this exact same thing, now what's happening between 4 and 1? 1 and a fourth, 1/4 and 1/16. And actually, I think this one's a little bit easier to see. What do I have to multiply to 4 to get 1? Well, I have to multiply 1/4 to 4 to get 1. What do I have to multiply 1 to get 1/4? Well, 1 times 1/4 is a fourth. And then what do I have to multiply to 1/4 to get 1/16? Again, that is 1/4. So if I do the exact same thing and say, okay, y is equal to a, and again, we look at what's my y value when x is 0. So my x is 0 here. So my y value is 1. My a value is 1. Times by b is the same thing. What am I multiplying each time? 1/4 to the x. And what we realize is happening here in b is as my x's increase, it goes from -1, 0, 1, 2, my y values are actually decreasing. And so what we call this is exponential decay. And this occurs, I don't know if we can see that again. Exponential decay occurs, actually, let's go back. Exponential growth occurs when my b value was greater than 1. Now my exponential decay occurs when we have a b value that's less than 1, but we also have to talk about, okay, my b value also has to be, so my b value is less than 1, but it also has to be greater than 0, because we've already talked about what it is going to be when it's when it is equal to 0. Well, it's just going to be 0 all the time. And then we can also see what happens when a b value is negative, and I'll show you that in this next example. So, similarly to the exponential growth functions, I have y is equal to 3 times a half times x, and y is equal to negative 1/3 times 1/2 to the x. I want to see what happens here. So 1/2 is my b value each time, and that does tell me I'm going to have exponential decay. And I have to see what happens when I change my a value. So here, weirdly enough, so if I do this first example, negative 2, and y is equal to 1/2 to the x, y is equal to 1/2 to the negative 2 power. But to make that a positive exponent, I have to take the reciprocal of a half. So that's going to be 2. 2 squared, that's equal to 4. And again, this is enough for me to tell me, well, at this point, I'm going to multiply by a half each time to get the rest of the numbers. So 4 times a half, well, it's half of 4? 2. 2 times a half, that's just 1. And again, this makes sense because my a value out here is 1. You can't really see it, but now I wrote it in there. My a value out here is 1. So that makes sense that when my x value is 0, what's my y value? Well, that's 1. Multiply 1 by a half to get the next value. That's just a half. A half times by a half, that is 1/4. Okay? Versus with the next function, again, I'm just multiplying these numbers by 3. So I have 1/2 to the x, that's right here. And now instead I'm multiplying it by 3. So this will be 12. 2 times 3 is 6. 1 times 3 is 3. A half times 3 is 3/2. A fourth times 3 is 3/4. Okay. And again, this makes sense because my initial value is 3 in this equation, both from the equation and from the table. And last but not least, this is negative 1/3. I had to kind of write it in kind of small because I messed it up, but it's negative 1/3 times by 1/2 to the x. And so this is really going to get me really, really, really small numbers. So if I multiply this by a third, because I'm taking the initial value, multiplying it by a third, the initial amount, multiplying it by a third, and then taking the negative of it. So what's 1/3 of 4th? Well, that's 4/3, but then take the negative of it, that's negative 4/3. 2 times a third, that is 2/3, but I have to take the negative of it, negative 2/3. 1 times a third, that is 1/3. Take the negative of it, that's negative 1/3. 1/2 times a third, that is 1/6. Take the negative of it, that's negative 1/6. And then 1/4 times a third, that is 1/12. Take the negative of it, that is negative 1/12. And again, what's happening here is we are still multiplying by 1/2 each time. Okay? And so now if I take my, I'm going to do the exact same thing here. Now if I take my graphs, let me just do this then. If I take my graph here, and I'm going to graph each function. So I'm going to do the purple one first. Again, where's my purple pen? I have no idea where it went, so I guess I'm just going to be doing it in blue. Yep, doing it in blue. Kind of disappeared on me. So my first point in my first graph is negative 2, 4. So negative 2, 4. 1, 2, 3, 4. Next point is negative 1, 2. Negative 1, 2. Next point is 0, 1. 0, 1. Next point is 1, 1/2. 1, 1/2. And then 2, 1/4. And what we notice here this time is that, I messed up the graph a little bit. Is now our graph looks like this. it's going down as our x's get positive, but again, it never crosses that x-axis. Never goes into the negative part. It always stays above the x-axis. Okay? Next question, next graph here. If I do negative 2, 12. So again, this is going to be one that I'm not going to be able to graph on here, but negative 2, 12 is going to be roughly right here. Negative 1, 6, negative 1, 6, 0, 3, 1, 3 halves, 1, 3 halves, and then last but not least, 2, 3 fourths. 2, 3 fourths. So here we go. That would be this middle function. And last but not least, I have to do this last one. And unfortunately, I'm going to also do this one in blue just to kind of make things, because I only have 2 colors right now because I don't know what happened to my purple one. But if I graph this last one in blue, it's be negative 2, negative 4 thirds. So negative 2, negative 4 thirds is 1/3 more than negative 1. Negative 1, negative 2 thirds. Negative 1, negative 2 thirds. 0, negative a third. 0, negative a third. 1, negative 1, 6. We're getting closer and closer to this, to the x-axis. Negative a sixth. 1, 2, negative a 12th. But here, instead, things are getting a little bit wider. Okay, so now it's flipped across the y-axis, but it's also it's kind of stretching out a little bit again across that y-axis, or it's kind of flattening towards the x-axis if you look at it that way. So instead of it speeding up really quick or going down really quickly, it is now going up slowly. Okay. So again, if you have any questions, please feel free to email me your questions, and I will try to get back to you as soon as possible. Okay. Please use the discussion boards. Please ask your friends. And again, if you need my help, please feel free to email me. Have a great day, and I will see you next time. Thanks.